What is isometric projection? Consider a cube placed in the horizontal plane with its faces equally inclined to the vertical plane as shown. Now if we join the diagonally opposite corners of this cube, then we get the solid diagonal of the cube. Now in the second position, if we tilt the cube in such a way that this solid diagonal is parallel to the ground or horizontal plane, the projections of this cube will be as shown. Now in the third and final step, if we rotate the cube such that this solid diagonal becomes perpendicular to the vertical plane, then the projections of the cube are as shown. What we saw here was the step-by-step procedure to create the isometric projection of the cube. The front view that we see here is the isometric projection of the cube. The word isometric comes from the Greek language, which means equal measure, and reflects that the scale along each axis of the projection is the same. In isometric drawings, the axes are equally inclined to each other at 120 degrees, and the coordinate axes appear equally foreshortened. Next is isometric axis. The lines OA, OB, OC, representing the edges of the cube, are equally inclined to each other at 120 degrees and are termed as the isometric axis. Next is isometric lines. The lines parallel to these axes are termed as isometric lines. Next is isometric planes. The planes representing the faces of the cube and other planes parallel to these planes are known as isometric planes. Now we will see construction of the isometric scale. While drawing isometric projections, it is necessary to convert true lengths to isometric lengths. This is done by drawing an isometric scale. To draw an isometric scale, first draw a horizontal line AB of any length. From end A, draw lines AP and AD such that angle PAB is equal to 45 degrees and angle DAB is equal to 30 degrees. Now mark divisions of true length on AP, and from each division draw vertical lines cutting line AD. The divisions that we obtain on AD gives us lengths on isometric scale. Let us draw the isometric view of a square plane. Draw a horizontal reference line and from any point draw the sides AB and AD inclined at 30 degrees. Now from points B and D, draw arcs and mark point C and join the lines BC and CD. This rhombus is the isometric view of the square in a horizontal plane. Now let us draw isometric view of a circle by 4-center method. A circular plane in the isometric view will be seen as an ellipse and is drawn using the 4-center method. The first step encloses the circle in a square plane touching it at points A, B, C and D. Then draw the isometric view of the square plane as shown. For drawing the ellipse, first draw the center lines and mark the points A, B, C, D as shown. Then join the longer diagonal and name the opposite corners 1 and 2 as shown. Now from the corners 1 and 2, draw lines joining the midpoints of the opposite sides. These lines intersect the longer diagonal at points 3 and 4 as shown. Taking 1 as the center, draw arc. Then taking 2 as the center, draw arc. Next, take 3 as the center and draw the arc, and then take 4 as the center and draw arc.
A hexagonal pyramid is resting on HP with a base side parallel to VP. Its orthogonal plan view shows true shape of the hexagonal base. So, let's construct its isometric view. For this, first enclose the plan view of the pyramid in a rectangular box 1, 2, 3, 4. Then, from any point 1 double dash on reference line, draw lines 1 double dash, 2 double dash and 1 double dash, 4 double dash, making angles of 30 degrees with the line XY. After that, locate points B double dash, C double dash, E double dash, F double dash by measuring the lengths of the sides of the hexagon. Now, locate point A double dash and D double dash as the midpoint of the side 1 double dash, 4 double dash and 2 double dash, 3 double dash respectively. Joining A double dash, B double dash, C double dash, D double dash, E double dash, F double dash, A double dash will form the isometric view of the hexagonal base surface of the pyramid. Now draw lines to join the midpoints of the sides of the rhombus in the isometric view to obtain the intersection point R, which is the center of the base. Next, draw vertical axis of the pyramid RO double dash of required size. OK, let's join the apex O double dash with vertices of the base. Now, take a look at the complete isometric view of the pyramid. Observe the invisible edges are shown as dashed lines.